The Sun, Our Star, Our Powerhouse, written by David Attenborough, BBC. Life on Earth relies on a constant supply of energy. This energy comes from the Sun. The Sun is a star, a giant ball of burning gas. It emits vast amounts of energy in the form of light and heat. This solar energy travels through space and reaches our planet. Without the Sun, Earth would be a cold, dark and lifeless place. The Sun's energy fuels everything on Earth. It warms our atmosphere and drives our weather patterns. Plants use sunlight to photosynthesize, creating the food that sustains almost all life. Even fossil fuels, like coal and oil, are ultimately derived from ancient sunlight stored in plants and animals. The Sun is the engine that powers our world.
The Biosphere, a symphony of solar energy. The biosphere is the thin layer of life that exists on Earth's surface. It encompasses all living things, from the smallest bacteria to the largest whales. The biosphere is a complex and interconnected system. At its heart is the flow of energy, originating from the Sun. Plants are the primary producers in the biosphere. They capture solar energy through photosynthesis. This process converts sunlight, water, and carbon dioxide into sugars, which fuel the plant's growth. Animals then eat plants or other animals, obtaining the energy stored within them. This transfer of energy from the Sun to plants to animals forms the basis of food chains and food webs that sustain all ecosystems.
Earth's energy balance, a delicate act. Earth is constantly receiving energy from the Sun. This incoming solar radiation is called insolation. However, Earth also radiates energy back into space. This outgoing energy is called terrestrial radiation. The balance between insolation and terrestrial radiation determines Earth's temperature. If Earth receives more energy than it radiates, it will warm up. Conversely, if it radiates more energy than it receives, it will cool down. This balance is crucial for maintaining a habitable planet. Changes in Earth's energy balance, whether due to natural causes or human activities, can lead to climate change.
Life's dependence on climate. Climate refers to the long-term patterns of temperature, precipitation, humidity, and other atmospheric conditions in a particular region. It is a fundamental factor that shapes the distribution and abundance of life on Earth. Different species have evolved to thrive in specific climatic conditions. Humans are also highly dependent on climate. Our agriculture, infrastructure, and health are all intricately linked to the prevailing climatic conditions. Changes in climate can disrupt food production, increase the frequency and intensity of extreme weather events, and spread infectious diseases.
Climate change is already impacting life on Earth, including human societies. Rising temperatures, shifting precipitation patterns, and more frequent extreme weather events are forcing species to adapt or face the risk of extinction. Humans are also adapting to these changes. We are developing new crop varieties that can tolerate drought or flooding. We are building seawalls and other infrastructure to protect coastal communities from rising sea levels. However, adaptation has its limits. If climate change continues unabated, the consequences for both human and natural systems could be catastrophic.
Climate change is one of the most pressing challenges facing humanity today. To mitigate its impacts and adapt to a changing world, we need a thorough understanding of the Earth's climate system and the factors that influence it. Climate science is a complex and rapidly evolving field. Scientists use a variety of tools and techniques to study past, present, and future climate change. This includes analyzing ice cores, tree rings, and other natural archives to reconstruct past climate conditions. It also involves developing sophisticated computer models to simulate the Earth's climate system and project future climate scenarios. The greenhouse effect is a natural process that warms the Earth's surface. Certain gases in the atmosphere, known as greenhouse gases, trap heat from the sun. These gases include water vapor, carbon dioxide, methane, and nitrous oxide.